Okay, now students, let us start with our first application. This is the application wherein we have to simulate the traffic signal on one direction. Traffic signal light on one direction, so that we have to simulate here. A transition from red light to the green light to amber light is accomplished by interconnection of a three T on timers instruction. So here it is strictly mentioned in the problem statement that you have to use on delay timers, right? And what is that sequence? The sequence is what? The time sequence of the lights are red has to be glow for 20 seconds, green has to glow for 10 seconds, and amber has to glow for 5 seconds. And this has to be sequenced, and this has to continue. Again, repeat from red, green, amber. Okay, so these are the sequence. But ensure that students, when it is mentioned, like red has to on for 20, green has to on for 10, amber has to on for 5 seconds. That does mean when green is on, red and amber should go off. So before going for any ladder diagrams, what we need to do? First of all, we need to find out how many outputs are there and how many inputs are there. This is the space for ladder diagram, and we are preparing number of inputs and number of outputs. Okay. Now students, in this case, probably or most of the times, what input switches that we want is to start the signaling process, to stop the signaling process, or in some cases we need to reset the signaling process. So these are the three switches generally being used in a traffic signal. So let us try to understand. First of all, I'll take, it depends on you students. Whether you are using normally open, normally closed, accordingly you have to select the symbols inside this ladder diagram. Okay, so what I'm doing, please try to follow me. I'm using here a normally open push button. So for starting the cycle. Okay, I'm using here again another normally open push button to stop the process, and one more I'm using here one more push button which is normally open to reset the entire cycle. Okay, so these are the inputs. So accordingly you will find this is a 0 number, this is 1 number, this is 2 numbers. So accordingly you can find the switches and their addresses. Okay, and what are the outputs? So we want three LEDs or three lights that should be glow in a sequence. So the first, let us say we will have this red, and second what we are having is, what is the next in a sequence? Green. So we'll write green. Okay, so you can put according to your signals also, but I'm just following because I'm just writing a ladder program. Okay, practically it will execute as per your requirement. So I'm just putting all these outputs as per the requirement of problem statement, and the last is amber. So these are lights. Okay, so these are the three lights, output light 1, 0, 1 and 2. Now whatever we are going to learn today is about ladder diagram. So I will just take this problem statement now to the simulation software directly, because whatever we are writing is now in between these two input and the output modules. So let us start with, today I'm going to give a demonstration of one more bit which is called as a binary bit. If you are looking at, if I close this, students, I should not explain you the entire things again. You are familiar with the software. So if I close this, you will get this window, right? So in this window, there are data files like output is 00, input is 1, I1, S2 is for status, and there is one more B3 for binary. Okay, if I click on that, you will get the data table for the binary numbers. So what does it means? These are the internal relay which doesn't we are not connecting to the external output devices. So it is nothing but the inner coil itself, but it is an internal relay coil. Okay, so it is not necessary to connect to any output devices. It will just when it get energized, we can use this signal. Let me explain how to use this. Okay, so I just close this. You will find that it's binary. Binary also has a table like here. See how to designate this B3:0/ if you are using 0 number terminal, 1 number terminal, 2 number, up to 16 terminals you can use at a time. So similarly, if you want to go for one more, so it is available up to around 100. Okay, up to 100 binary bits are available. So how to use that? So I will go to the again modification here, students. my input start switch is, I'm using this 00 as a start switch, so it is normally open. So what we have to do, you have to just right click on the symbols to change. Okay, so I want all these three normally open push buttons. Fine. Then I will start with first rung. I'm writing that rung not for the coil to energize the LEDs, but I'm using here internal relay coil, that is binary bit. See here, how to use. First of all, instead of directly starting the red light, okay, to be glow first, okay, as per for the 20 seconds. So what I'll start, I will just give a start with the first rung. See how I'm writing this first rung. I will take start button to start the process. So here I'm using normally open. If I'm using here normally open here, so whenever I press it, it has to energize. So I'll just give the address. Either you can click over here on the question mark and you can assign the address I:0/0, or what you can do, just go to this black box you can find just against that switch, hold it, drag it, and just leave on question. You will get the address automatically. Okay, so after that I want output coil, but here I'm, instead of using the output coil for the red light, I'm using a binary bit here. So how to use that, how to assign this address? Either just double click on, write it B3:0/0. This is what a binary bit, so it will get energized. Okay, and then I will go for a latching for this bit. So I will use a latching. So I will use one more normally open, and I will assign this address. How to assign address? Either you have to type over here or just go here, hold it, drag it, and leave at question mark. Okay, this is what the latching. So let's see what happens in this case. If I go to the run mode, download, okay, and then run. So if I press it and leave this push button, I'm expecting output coil should get energized, even though by releasing the push button. See here, pressing release, but still you will find binary bit is energized because there is a latching. Even though I make the contact and relieve the contact, even though the output is, this process is called as the latching, right? Okay, now I've done this latching. I came to know that if I'm trying to stop by any means, it is not going to stop. See, even though if I'm pressing this button, it will not stop the output. So in that case, we require one stop button. In that case, we require, and always remember, when you are in a run mode, software does not allow you to have a modification. Otherwise, if you are in a run mode and if you are trying to modify your software or ladder program, that will directly affect on the process. Okay, any accident may occur in the actual plant, because you are just running your plant through the PLC. So always remember, you have to go back again in edit mode, and then you have to go for a modification. After a modification, you have to download it to the hardware. So for us, hardware is this one, right? So I want to go for one stop button here. I'll just add stop button. So what I'm using here, it is normally open. So I'll just go for normally close because I want to stop the process. So when I press this, it will de-energize because it becomes high, it becomes 0, and your bit will go for stop the entire process. Okay, so I will assign this address for the stop button. Okay, simultaneously, I just assign the name. Okay, this is going to be a start push button. Okay, this will be edit symbol, stop push button. Okay. And this is a binary. I should not assign any name because it is an internal relay. It is not being connected to any output. Okay, and I supposed to be right here, edit run. See here, I will say that LD on. Now we are written the first rung by using internal relay coil. Now next rung we have to write to turn on red light for a 20 second. Now here there is a time constraint. So in this program, we have to use the timers. Okay, so they are strictly said as you have to use T on timers or T on timer instruction to turn on a red light for 20 seconds, green light for 10 seconds, amber light for 5 seconds, and the sequence should repeat itself. So unless and until you stop the program, that means that we are using first rung to start in the stop program unless and until the stop button is being not pressed. The sequence of operation keep repeat itself. So we have to ensure that even after this first sequence is finished, it has to continue with the next sequence. Okay. So let us try to write a run for red light to on for 20 seconds. So here we are using T on timer for 20 seconds. So first of all, we have to start this run. To start this run, we are going to use normally open and we are assigning the address of internal relay coil. So it will ensure that the energy is available for this run when the process has started. Now we are going to use on delay timer. So here you can see that timer counter. So on delay timers, I'm using an on delay timer. So already in the theory class, we learned how to assign a timers and what is the time base, what is the preset value, what is the accumulator, everything we discussed in theory class. So here I'm going to assign a timer. I'm using the 0 number timer. So how to assign? You can see here, students, in the file, 4 number file is for timer. So T4, or rather you can use this to assign the timer itself. Okay. So T4 colon 0, this timer I'm using for red light or red indicator. So that I use T4 colon 0. Now time base, it is a by default quantity which is being given by this software. In some software, it may be 1, time base may be 1, in some cases it is 0.1, in some cases 0.01. Okay, it defines the increment. When your accumulator is starting accumulating the values, it will decide in what incremental order it has to reach to the final preset value. So here time base is 0.1 and we have to set the timer for 20 seconds. So that does means what is the total preset value? 20 seconds. That means what we have to set for 200. Preset value should be 200 because the 20 seconds is nothing but the product of time base into preset value. So if I am setting a 200 into preset value, this is what the 0.1, I am getting a time in second, that is 20 seconds. So my preset value I am going to set here is a 200. So total time that I have set for red indicator, it is 200 into 0.1, that is a 20 second, right? An accumulator, when timer starts, it will start accumulating the value and we can use the bits of a timer, enable bits and done bits to start the light indicator that will show the red indicator is on for 20 seconds. See, input is high. When timer T on will start, when the input for this run or timer, if it is on, then we can say that the timer start accumulating the values. Okay. So when input goes off, timer resets to the zero accumulations. Okay. So that is called as a reset of a timer. To reset the timer, the input, if you make it false or a zero, then timer resets. If the input to the timer, if it is high, if it is a true, it will start accumulating the time. Okay. Now see, let us try to run this run to understand what is going to happen here. So I will start the process. So when I started the process, you can see that internal relay coil has started and it provides the input, high input to the on delay timer, and on delay timer start accumulating the value. You can see here. And simultaneously you can see that enable bit is high. Then bit is off. When the accumulated value is equal to preset value, then done bit becomes high. So we can use these two conditions. So let us go offline. Then we will use normally open, and this we will assign to the red LED. So I'll just change the color. It is a red. Okay, it's already a red. So this will be a red indicator. Okay, red indicator. Fine. So this red indicator has to remain on for 20 seconds. So you might have seen here for this timer run, when input to the timer. When it becomes high, it start accumulating the value, and simultaneously you might have observed that enable bits is also high when the timer start accumulating the value. So I can use this enable bits to start the indicator. Okay. So how to assign that? T4 colon 0 number timer slash enable bit. So I'll use enable bit. So when enable bit is high, it becomes high, and when it becomes high, it will turn on the red indicator coil. Fine. Okay. Now the condition is what? It will remain on because Steve, even though accumulated value is equal to preset value, it remains high. Why? Means enable bit is still high. Okay. But it has to turn on for only 20 seconds. So what I'm going to do? I'm using done bit here. Okay. So I'm using a done bit condition to turn off. But how, which normally close? Why normally close? Because when enable bit is high, done bit is low, and when done bit is low, it should be high, and when done bit is high, it should go low. That means what? Its value should be 0. It breaks the rung, and red indicator turns off. See here. I'm assigning T4 colon 0 slash done bit. Now see, let us try to run this. Okay, download, then run. So we have to stop, reset. Now we have to reset. I have not added the reset button, but we will stop this program. Start. When the program has started, you can see that enable bit is high, and on delay timer is accumulating the values. Done bit is off. See here, done bit is off. So when it is 0, it becomes 1, and indicator is on for a 200 preset value. That means for 20 seconds. And after 20 seconds, you can see that done bit is high. Then when it is high, it becomes 0. It terminates the rung, and red indicator goes off. So the first condition is being satisfied here. Red indicator turns on for 20 seconds. So after 20 seconds, red indicator goes off. So first condition is being satisfied by using this timer. So for next green indicator, similarly we are going to use the next condition. Okay. So for a green indicator, we have to go offline. Always remember, you have to go offline. Now to start the next timer, so I'm going to use one more timer for green indicator. See here. But to turn on this timer, we have to take input from the previous timer. Means what? After 20 seconds, done bit becomes high. So when done bit becomes high, it should turn on the next. Means what? After 20 seconds only done bit becomes high. After 20 seconds, the next timer should start. So I'm using here input for the next timer T4 colon 0 slash done bit. Fine. So when done bit becomes high after 20 seconds, then and then only next timer to turn on green light for 10 seconds should start accumulating the value. Now this timer I'm going to use here T colon T4 colon 1. Okay, so already I have used 0 number, so I'm using 1 number timer. And now the preset value should be, we have to turn on green light for 10 seconds. So I will set the preset value 100 because the total time is nothing but time base into preset value. So that is 10 seconds. Okay. Now let us take a rung for green light. So what should be the condition to turn on the green light? When enable bit of the timer 1, if it is high, it will energize this rung. Green light should turn on. So I will take the input T4 colon 1 slash enable. When enable bit is high for this timer, 1 number timer, then it should glow the green light. So I'm using green light here. So let us write this green indicator. Okay. Green indicator. So whether it is green, yes, it's a green indicator. But it has to run for 10 seconds. So after accumulating the value up to 100, then and then only done bit becomes high. So when done bit becomes high after 10 seconds, green light should turn off. So I'm going to use a condition done bit. T4 colon 1 slash done bit. Okay. So let us check the condition. Okay. Now we'll stop that because yet I have not added the reset button. I have to add the reset. Okay. So we are playing with start push button and stop push button right now. So entire process is, see here, internal relay coil is de-energizing when I stop the entire process. Now let us start this. When I started, you can see that red indicator is on for 20 seconds. When done bit becomes high, it goes off. See here. Here also you can see that red light. After 20 seconds, it goes off. Yes. And then green indicator turns on for 10 seconds. Green indicator turns on for 10 seconds. Okay. Now after 10 seconds, you can see that green indicator goes off. Fine, students. Now we have to write a run for amber for 5 seconds. So to start the timer for amber, again we have to go offline. So here you can see that when I go run mode, download and say run, you can see that here it is showing online. But to edit the program, I have to go offline. So I have to write a run for amber. Now this timer that we are using for amber should take the input from one number timer, T4 colon 1. We'll take that. So it should take the input from T4 colon 1 slash done. When done bit is on, the next timer should start. Okay. So I'm using one more timer here, T4 colon 2. And what is the preset value? Should be 50 because 5 seconds. Right, students? Then we have to turn on amber. Now to turn on amber, so we will take an input T4 colon 2 slash done bit. Okay. So this done bit we are taking as an input, and based on this done bit, we have to turn on amber light. So assign the address and let us write this edit symbol, amber indicator or yellow indicator you can say. Right. Now again to stop this, for after 5 seconds it has to stop, go off, right? So I'm using done bit. So T4 colon 2 slash done bit. Okay, so here to start this amber light we have to use an enable. Do correction here, enable. Now check this program. Download, run. So we have to stop first. We have to stop entire program. Then let us start this. When we are started, here you can see that the red indicator is on for 20 seconds. See here, red indicator, only red indicator is on. So after 20 seconds, done bit becomes high and that will terminate this run and red indicator goes off. Then as soon as it goes off, we are using a done bit to start the next timer. Here you can see that we are using this done bit to start this timer. After 10 seconds, green indicator goes off. Now here it has started amber. Amber goes off by after 5 seconds. But it goes for one cycle only. But as per the condition, the sequence then repeat itself. So it has to keep repeating itself. So what we have to do? We have to use the done bit of this timer to start the timer number 0. So what I'm doing here? Go offline. So here I'm using input to start this timer because unless and until I'm starting this timer, no? It is not possible to have a cycle or a repetition of the same sequence. So I use here done bit T4 colon 2 slash done bit. Okay. Now check whether it is repeating or not. Download. run. So we have to stop first and then start. And we have started. So red indicator is on for 20 seconds. See here you can see that accumulator value is accumulating. Alright, and red indicator is on for 20 seconds. When 20 seconds accumulator value is equal to 20 seconds, then done bit is high, then it will turn on the red indicator. It will start the next time for 10 seconds, and green indicator will turn on for 10 seconds. And then what is going to happen here? For 5 seconds, see again red indicator is on. So cycle is continuing. See here. Up to 200, red indicator is on. That is a 20 second. This will be turned on for 100, that is a 10 second, green indicator. And then you find amber indicator for 5 seconds, that is up to 50. Then it will start again red indicator. So this cycle keeps on continuing. Now we have to add a reset button. Okay, so go offline, and what we want to reset? The entire cycle, but we have to keep the program on. Okay, to reset the cycle, not the entire program, to reset the cycle. So what I'm using, one more push button. So I'm using here one more push button to reset the cycle. Since I'm using here normally open, so to stop that I'm using normally close inside symbol. Okay, so when it becomes 1, it goes 0 and it will reset the entire cycle. Reset means what? It will just keep resetting. Suppose right now it is running at green light, so I have to start this entire cycle from red light, so it will get reset. Okay, now I'm using this symbol, fine, and that is for a reset push button. Reset push button. Okay, now check. Go to the run mode, so it is online. Now we have reset, we have stopped it, and then we have to start it. So when you have started, you can see that red indicator is on for 20 seconds, then green indicator will start for 10 seconds, on for 10 seconds, and amber is on for 5 seconds, and the cycle will repeat. And now green has started. Now suppose I want to reset the entire cycle, so what I'll do, I'll just go for reset. So you'll see that even though green light was there, so I can reset for red indicator. So that is the purpose of reset push button. Hope so you understood. Try it. We are going to discuss the next application for continuous filling process. Hope so students you understood a ladder programming for traffic signal. Now let us try to understand a next application. In this application, it is a continuous filling operation by using conveyor systems. So in this operation, what we are having, a hopper, solenoid valve, level switch, a conveyor motor, photosensor, photodetector. We are using start push button, stop push button, and along with to indicate the processes. So what we are having, if the process is in run mode, so we'll use a run LED light, standby mode, and full mode. So these are the LED information, that LED lights that gives us the conditions, whether system is running, whether system is at standby, whether this box is full. Okay, to indicate all these operations, so we are having these LED indicators. So let us try to prepare a ladder diagram just like what we learn in traffic signal. In this problem statement, it is mentioned it is continuous filling operation. This process requires the boxes moving on the conveyor to be filled automatically, positioned automatically, and filled automatically. The sequence of operation for the continuous filling of process, it is given as below. So try to understand, this is nothing but the event-based operation, and PLC is mean for event-based operation. So let's try to understand event-based operation and try to identify what are the input devices and what are the output devices, and in between we will write the ladder programming for continuous filling operation. So first of all, Let us find what are the input devices, what are the output devices, and in between we'll write a ladder program. Fine. Start the conveyor when start push button is momentarily pressed. Even though it is not mentioned like a start push button, but it is mentioned like it is a momentarily press, means what, for the moment it is pressed and then release that push button. So ultimately you will come to know that this is what the push button which is being used to start the conveyor system. So what we want to start the process, we want a start push button. So I'll just put that start push button over here as an input device. So I'm using here a start push button, and that is normally open. So it is start push button, start push button. Then stop the conveyor when stop push button is momentarily pressed. So I'm using here push button to stop the operation. So here I'll be having a little bit change. Instead of going for normally open, I'll use here normally close for the stop push button. Okay. I want to explain I'm using a different input switches. So what changes will be there in the ladder program? So that we are going to discuss in this problem. Now we are selected here normally close push button to stop the operation. Next is to energize the run status light when the process is operating. So we want one output device which shows us the operation is in process. So to show that we are using a run LED light. Energize the standby status light when the process is stopped. When the process is stopped, to indicate the process is not running, so we are using one LED light that will show the standby status. So we are using here one LED light to show the standby status. Standby status. Stop the conveyor when the right edge of the box is first sensed by the photosensors. So here we are using the photosensors to detect the edge of box, and when this photosensor is detecting the edge of box, the conveyor motor should stop over here. So we are using here a proximity sensor. It's a proximity sensor. We'll write it as photosensor. When this photosensor detect the edge of first edge of box, the conveyor should stop. That is nothing but the conveyor motor should go off. So here we want conveyor motor. So we are having a conveyor motor. So it is motor. We'll write it a motor. With a box in a position, the conveyor stopped. Now when the box is at a position, conveyor is stopped. Open the solenoid valve. Now the solenoid valve will get open and allow the box to fill. Now it will allow the box to fill. So we want one more output, that is solenoid valve. So we are going to represent the solenoid valve. So we got by the time 4 output devices. Filling should stop when the sensor level sensor goes true. Means what, here we are having a level sensor. When box is full, then level sensor will detect the box is full now, and the filling process should stop. That does means the solenoid valve close the nozzle and filling process will get stopped here. So here what we want, one more device, that is another sensor, that is a level sensor. So here we will write level sensor. So we got 4 input devices and by the time 4 output devices. Let us continue with the next event. Energize the full light when the box is full. Full light should remain energized until the box is moved clear of photosensors. Until the box is clearly moving, means what, photo detector is not detecting the box. Until that, the indicator, full indicator should glow. So one more output device what we want, it is nothing but full indicator. Okay, so that will show the condition of full. Box is full. So we got by the time 4 input devices and 5 output devices. With this input and output devices, now let us prepare a ladder diagram by using simulation software what we are having here. Now let's just start. Just like in traffic signal, here also we are going to use a binary rung or binary bit rung in order to start the process. So let us start. The first event. Now when you are writing a ladder program, first thing is what you should know: what are the input devices, what are the output devices, and based on that, then we have to read and try to execute the events which are to take place in a sequence one after second. And by knowing that sequence, we have to put that in terms of ladder diagram in the PLC program. Okay. So let us start by writing a run command here. So here what we are writing, the program or problem statement, problem continuous filling operation, continuous filling operation. In addition to that, you can write also your name, your roll number, and division. All this essential information you can write, and then you can start to write a first rung. The first rung, as I told you, we are going to write it for a binary bit to start the process. Now in order to start the process here, the start the conveyor when start push button is momentarily pressed. So I'm using here, this is what the start push button, and I'm using normally open. So I have here a normally open push button. So 00, this is what the address for the start push button on the hardware. The stop the conveyor when stop push button is momentarily pressed. So I'm using here, see now it is normally open, but what I'm using here, normally closed. So I will change that status to the normally closed. So as I close it, you can see that it becomes high. Okay. Next, what we want, proximity sensors. The proximity sensors will become on when it detects the edge of box. So I'm using here a proximity sensor. So for the sake of understanding, I'm using here on off button. Okay, so that I can able to understand whether program is operating correctly. In a real time, if you are trying to execute, you are having hardwares, and the operation of that hardwares will be taken place with a photo switch and level switch itself. So to simulate that operation of photo sensors and level switch, we are using here two switches that will execute the operation of photo sensor as well as a level switch. Okay, so these are switches. One is address 2 is for photo sensor and address 3 is for level sensor. So let us start with rung number 1. So I'm using here rung number 1 with binary bit. So I want to start the process. Entire process has to be start with the when the start push button is pressed. So when the start push button is pressed, so I'll just assign this address. When the start push button is pressed, start push button. When start push button is pressed, it will energize the run and energize the output coil. So here output coil, instead of using the first run mode LED, so I want to use this run to start the entire process because this process has to go in continuation. So I'm using here binary bit. So how to go for a binary bit? So simply close this. Here you can see that B3, file number B3 is assigned for binary numbers. So you can use any of this binary. Similarly, if I'm using B3 colon 0/0, you can simply type here, or you can hold this bit, drag it and leave it on the question. So you will get that address being assigned to this one. This binary bit is internal coil which is not being connected to any other devices. So I can use this for a latching. I'll use here normally open and assign the address. Okay. Now you can see here when I press this momentarily, this symbol get energized. It will energize the output internal relay, and when it get energized, it will energize this bit. Even though if I'm releasing the push button, it remains on, okay, until this rung is being stopped by the stop button, right? So I have to add the stop button to stop the process here. So here I'm using right now normally close. Okay, let us try to understand here what is going to happen. So I'm assigning this address, and let us try to run this download. and run. So what is going to happen if I press it? See, it is high, so it will be high. Okay, and then if I press it, you can see that the output is energized, and when it energizes, it will energize this, and it will just simply bypass the start push button and will remain energized even though if I release this start push button. Okay, now to stop this operation, to stop this internal relay coil, I have to press the stop button. So as soon as I press the stop button, the continuity between these two will get break and your output relay will de-energize. So this is what start and stop process. So again, offline mode. So first run we have to write. Now we have written this for by using an internal relay. So using this information, now we can write a next run to start the, see what is the next run? Start the conveyor when the start push button is momentarily pressed. So we have started the first run, but we have to start the process, conveyor process. Stop the conveyor when the stop push button is momentarily pressed. So we have executed start and stop operation, okay, to start the process and stop the process. Now next is energize the run status light when the process is operating. Now next run we have to write is for run status light. Okay, when the operation is running, so run status light should glow. Okay, then I will take this bit information to start the process. Okay, then we'll use output relay, and that we have to connect to the output LED that will indicate run status. So I will write here run light. Okay. So when process is running, you will find this run light is glowing. Okay, next you can execute it, download, go to the run mode, then see I'm going to start the process. So you can see that as soon as I started the process, the conveyor has started, a run light should glow. So it is happening over there. I have satisfied through this first, second and third condition. Okay, now let us go for the next condition. Go offline. Next condition is what? Energize the standby status light when the process is stopped. When the process is stopped, that means what? When it get de-energized, the run light or the process is de-energized, then your standby LED light should glow. So I'm going to use here and then standby. Assign the address from the run light. When run light goes off, that does mean process has stopped. And when process has stopped, then standby LED should glow. So I assign the second address. So I'll write this symbol. It is standby light. Now let us see what is going to happen here. Whether it satisfy the condition. Okay. We have to stop the process. We have stopped the process. You can see that when the process has stopped, you can see that standby light is on. Conveyor is not running, run light is off. When run light is off, that does mean process has stopped, and when process has stopped, then it should glow the standby light. So it is being done. See, when we are starting conveyor, then you can see that standby light is going off. Okay, and the motor or conveyor is in a run mode, that will be indicated by run light. Okay, fine. Next, go offline. Next condition is what? Stop the conveyor when right edge of a box is first sensed by the photosensors. Now we have to stop the conveyor. So here we are going to use a conveyor motor. So here what we are using, a run for the motor. So condition is what? Stop the conveyor when right edge of a box is first sensed by the photosensor. Okay, before satisfying this condition, we have to ensure that when the process is started, the run light is glowing, the motor should start. Okay, so here I'm writing a run for motor. So I will use a run light address to start the motor, and here I'll use this coil as a motor coil. So here motor coil. Okay. As run light is glowing, you can see that motor coil is energized. When process is stopped, then run light goes off. It will turn off this bit and it will de-energize the motor coil. Fine. So it will satisfy. We have given the condition for starting the motor. Now to satisfy this condition, stop the conveyor when the right edge of a box is first sensed by the. So motor has started now. Motor has started. When we have started the process, motor has started. But motor should stop when the photo detector will detect the first edge of box. So we have to write a condition here, right? When photo sensor is detected, see photo sensor. Photo sensor. Now see, when process is started, it is energized. Since the photosensor is open, it is energized, motor coil is energized. That means what, motor is on. But to stop the motor, photo detector has to detect the box. Okay. So now when it becomes high, it should, this symbol should go off or get de-energized. Motor coil should de-energize and motor should stop. Okay. So this condition is being satisfied here. When the box is in the position and the conveyor stopped, open the solenoid valve and allow the box to fill. When box is in a position, now conveyor motor has stopped, and because photosensor has detected the first stage, that means what, when the box is at in the position, motor has stopped and conveyor is not running. Okay. With the box in a position, the conveyor stopped, open the solenoid. Now we have to open the solenoid valve. Okay. So condition to see, condition is very important to open the solenoid. Box is in a position, conveyor stops. So conveyor stop, how do you come to know that conveyor stop? When run light is off, that should be condition. So I'll put that condition. Okay. So when it becomes 0, it has to be high to operate the solenoid valve, right? The first condition. Second condition is what? Allow the box to fill. Means what? Box is empty. So I'm going to use one more sensor, that is the level sensor. So level sensor is off. Right now it is off. So I can use a condition for level sensor. So here it is, level sensor. Level sensor. So see the condition. When motor is off, means what? Motors has stopped. Level sensor is off. So when it is open, it should be high to start this run. And then what we have, photosensors. Photosensors already detected the box. So we'll put that condition. Okay. And then we'll assign the address for the solenoid board. So this is solenoid board. Fine. Now let us check the condition to start the solenoid. See here, with the box is in a position, that means what, photosensor has detected the position. Then conveyor has stopped. Yes, it is being stopped because it becomes high when the motor goes off. Run light is goes off. It becomes high. Level sensor. Level sensor has not detected the full position, so it becomes high. So if three conditions being satisfied, then the solenoid valve is operating, okay, for the filling process. Then next is energize the full light when the box is full. So now box is full and we have to energize the full light. So for that, but how the system is come to know that whether box is full? So level switch has to detect the full position. Means what? Now box is full, it will be detected by the level switch. Okay, now we have to write a condition for a level switch. When level switch becomes high, it becomes high. So I'll just assign the address over here. This is the level sensor. And next, the full light should remain energized. Full light should remain energized until the box is moved clear of the photosensor. So we have to use a condition of photosensor until the photosensor clears the detection, the full indicator should glow. So photosensors, I'll use here photosensor, and then this is going to be full indicator, full light indicator. Okay, when box is full, it will glow. Okay, now check whether all some conditions are being satisfied or not. So download. Let us check that program whether it is running satisfactorily or not. So first of all, we have to stop the operations. Okay. Now when the operation is being stopped, you can see that standby light is on. I'm going to start the operation. So operation has been started. Run light is on. Motor is on. Right? Motor is on. So conveyor belt is started. Then when the photosensor is detecting the edge of box, then motor should stop. Now here motor has stopped, but run light is not stopping. We have to assign the condition for run light. So that means what? When the photosensor detects the edge of box, run light should go off. Okay. So we'll assign that condition. So we'll assign when photosensor detects, that means what? It has to stop. Okay. So photosensor, we'll assign this address, and run light should on when level sensor detect the full level in the box, or full light indicator is on, then it should start running. Okay, so I'll add it in a parallel because it's a or condition, right? Full light, fine. When photosensor detects the edge, light should stop, and when full light is on, then it should turn on the LED, run the LED. And also we have to assign the condition for the motor coil, for the level sensor or the full light, anyone you can assign here. Same condition that of run light. So we will assign that full condition, full light condition. Now let us check now. It is running. We'll stop first process, entire process. Now see, something is wrong because solenoid valve should not operate in this case. So let us try to understand what is wrong here. Level sensor is detected. See now, we have to stop the process, start the process. Now when we have started the process, you can see that run light is on, motor is on. Okay, now when photosensor detect the edge of box, then motor should go off, run light should go off, and solenoid has to operate. It has to on for the filling operation. Okay, it has to on for the filling operation. Okay, then box is full, level sensor will detect that box is full. Now when box is full, you will see that full light is on, motor has started, run light is on, that is the conveyor has started, solenoid is off, So, but what is going to happen here? It is expected the full light should remain on energized until the box is moved clear of the photosensor. You know, this condition is okay. Now, when let us check that full light is on, so the detection of photosensor is off. So you can see that motor is on, run light is on, and full light is off. So you can see that this is what the program for continuous filling operation. Okay, if you are having any doubt, any difficulty to understand this, you can put a message